Um, so good morning, everybody. Our topic is about cranial and facial implants. And Ossdesign is a Swedish medtech company that is located in Uppsala. And they produce these regenerative implants for cranial and facial surgery. So it was Dr. Thomas Engstrand. He is a craniofacial surgeon at Karolinska University Hospital. And he observed that there were complications with healing after the surgery. So he always wanted to develop more techniques from what was used then. And later he collaborated with Professor Hanken Enquist, if I'm right, and with his team in Uppsala University. They founded the Ossdesign in May 2011. And they mainly produce two kinds of products, that is cranial implants and facial implants. And what makes them stand apart is that the design of their implants, that is, it has a mesh-like mosaic design, like with a mesh, titanium mesh. So the advantage of this is the load is transferred onto the mesh so that the tissue growth is much better. It's not infectious, or it's better that way. And yeah, it has, since they use these bioceramic materials, it has a very good healing properties. And the main challenge with facial implants is again infection rate after the surgery. But they use the calcium phosphate reinforced with titanium, which has very less infection rate, and they do not require these immunosuppressions and stuff. And about the market analysis, globally the cranioplast market is dominated by North American and South American companies. But yeah, here we have taken 5 companies and compared as like how many products they produce. And as we can see, Stryker is a US-based company, and they produce the most amount of products, numbering up to like 558 products. Whereas Ossdesign is yet a developing company, and they produce around 3 products, and they are spread in most of the European countries, and now they are into US market as well. So what is cranial surgery? It is the restorative strategy to correct the bone deformity. And depending upon the complexity of the deformity, the surgery can be classified into 2. Brew hole surgery, when it is a less complexity in the defect, and a skull-based surgery when it is a larger complication. Materials. It is very important to select the right material for producing these implants, and they look forward for certain characteristics in the materials to use. And these are some of the important characteristics. That is, they need to be biocompatible, and the outcome after the surgery has to be satisfying. And the production time and infection rate are very important again. And these are the few materials that are commonly used. So it's been a lot of development from in the techniques for cranial surgeries. Well, the first one was started in late 1800s, and it was frame-based stereotaxy, and it was developed by Horsley and Clark. It was basically they found a device that could be fitted onto the patient's head, and it was a plastic. It was basically a plastic plate with few lead markers. And later it was developed for frameless stereotaxy, where there was no frame used, but there were single markers that was separately attached on the head. And this technique was further developed into markerless pair point and marker-based pair point and surface registration. Amongst these, surface registration is more widely used because it uses 3D printing, so it helps in providing customized implants from patients to patients, so it helps in getting better results. Now, Minshu will be explaining more about the techniques and materials.
Okay, and I'm going to introduce you more details about the materials and the techniques used in bone graft area. Since ancient times, both organic and inorganic materials are used in implantation. But nowadays, we classify the alloplastic materials into three different types: the bioceramics, polymers, and the metal. As compared to the beta TCP, is have a higher degradation rate, so it can be absorbed in our body after a period. The second one, the bioglass, is kind of different. The main material of bioglass is the dioxy silicon. It's not based on the calcium. This one is also degradable, but it cannot be used as the stress support part. The polymer family is a really big family, and I only show four really popular materials here. The PMMA is a transparent material, and it can work both in liquid and solid status. GA, this one is quite different, but it's the first material that approved by FDA, and it usually used as a matrix in vivo for cell growth. And for metal, titanium is really common, and we always heard about the titanium used in medical area. But actually, pure titanium is not that usually used in medical, and we usually use titanium alloy. And chromium is also a candidate, but it's not that much use because it have a higher risk of immune response for patient. Oops. And here are the product, and it have the size limitation. The chemical-based HA is compared with the Caro, it has lower strength, but it's also strong enough for cranial and facial reconstruction and bone and spine repair. Let's move on 3D printing. When we do product design, the first thing we're gonna do is to design the model. And the most commonly used app software is CAD, and the design is pictures just like this one. And after we have the design, we are going to the printing technology choose part. Which kind of techniques we are going to choose? They have 5 different ones. The first is solidification of powder. This is use laser as a resource to melt the powder material. And the second one is photopolymerization. This different is use UV light to solidify the photocurable resins, but this is used for liquid material. And the third one is extrusion, is to press out the melted material from the machine. And the fourth one is the direct energy deposition. This one usually used in metal and use different kind of high energy resource to melt the material. And the last one is kind of different, is sheet lamination. And this one is to use a material sheet to cut them into different shapes and glue them together. And the last important part of 3D printing is the printing material we already showed before. And here I have a short video for how the 3D printing works. And first, the 3D design and apply them into the machine. You can see the 3D printing is worked layer by layer. And after all this process is really easy to take off from the machine. And also, we can see from here there's nearly no material waste, so it's really eco-friendly. And also, if you don't want this material anymore, you can apply it back to the material and reuse it. So after all this, what materials and 3D printing tech that used by Ossdesign, the company we are targeting at? The material they use is the titanium reinforced beta TCP. They use the titanium mesh as a support and use 3D printing technique to cover the beta TCP over this titanium mesh. And this design can have a really good biocompatible in vivo, and it can last for a really long time. And also the titanium mesh inside can provide a really good strength of the whole product. Also, it can merge to the host bone and tissue after a period, so it's really preferred by by patients. And the method they use is DMLS. Is one kind of solidification of powder, the first method we showed on last page. And they choose this method is because it's really suitable for metal, especially titanium. Use DMLS can give the whole product a better mechanical properties, but the only drawback is this method cost a little bit cost really high. And but I think if this product can cure the patient is not really important. And let's invite EA to show you some.
And it's mostly like the traumatic injuries of the army person. People in the army, and how they use tantalum cranioplasty to improve the defects or to solve the injuries. In this case, the person is a 23-year-old male patient who actually got injured while playing baseball in the army. In the army playground, and he was suffering from a subdural hematoma, and it was temporarily drained. And this is the place where the subdural hematoma. The patient exactly is a 23-year-old male patient who has suffered from baseball injury, and which has in turn resulted in the subdural hematoma in the submandibular region. This subdural hematoma was temporarily drained, and the patient returned to his position or job or position, whatever. And exactly 2 or 3 weeks later, he got involved in a fist fight and got injured in the same place, resulting in again involving subdural hematoma. So this was temporarily drained, but since he is the army personnel and is more prone to get injured frequently, tantalum cranioplasty was used. And this is the site where the tantalum cranioplasty was implanted. Case studies two is usually is the reason one, which is usually run by the Ossdesign. And the patient is a 53-year-old male patient who was severely injured by his neighbor with an hammer few years before. And even after 24 surgeries, which involved autologous grafts, surgeries and everything, it seriously existed. The problems existed because of graft rejection, protrusion of the skin, and resorption. So finally, when they approached Ossdesign, they used applied bone morphogenic protein 2 inductive thing and to form a cranial implant. And this is how the first this is before the cranial implant. This is after the 6 months of the cranial implant, and this is exactly after the formation of the bone formation. Case study 3 involves a patient who was involved in a vehicular accident which resulted in a commuter cranial bone fracture. And the first CT exactly shows vein in the right parietal region where there are skull defect, and the second CT shows skull lesion in the parietal region. So after consulting the Ossdesign, after getting information like this CT scanning and after involving areas like CT scanning, PET scanning, etc., to get the information for the get information so that the implant I conclude my speech by saying that the cranial implant is mostly emphasized in European and American countries, but the development and technology, compared to the past and present, the development and technology has lessened the complications involved in the cranioplastic surgery. And if this has been applied throughout the world, it will reduce the